Hello and welcome to this video to accompany the Further Maths Conference Calculus session. In this video we're going to look at the third technique that you can show your students that shows some of the connections between calculus and other topics in maths. And in this one we're going to look at how the inverse tan integrals can be related to transformations of functions. So the first thing to begin with is to look at how we can show that the integral of 1 over 1 plus x squared is arc tan x, or the inverse tan of x. Well, the first thing I'm going to do is think about the derivative of tan x. If I draw a tangent here to the curve tan x and I put a gradient triangle on here, I can think about what the height of that gradient triangle is for base 1. Well, if y is tan x, then dy by dx is going to be sec squared x, which can also be written as 1 plus tan squared x. And the reason I'm doing that is that we can observe that tan is the y value. So we can say that at any particular point, if we think of this as a general point with coordinates x, y, we can say that at this general point x, y, the height of the gradient triangle is going to be 1 plus tan squared. Tan is y, 1 plus y squared. And that means that this is 1 plus y squared. Now this is useful because we can then flip the whole thing by reflecting it in the line y equals x and think about the inverse tan, or the arctan function, and this whole gradient triangle is going to flip over here at this point there. So this now is our new point x and y, but all the other x and y's on our diagram have been interchanged. Therefore this height here is 1 and this distance here is 1 plus x squared, because all the x and y's have been interchanged. What that means is that on this graph dy by dx is 1 over 1 plus x squared, difference in height divided by the difference in the width of this triangle here. And that tells us, by the fundamental theorem of calculus, the integral of 1 over 1 plus x squared dx is arctan x plus c. So that's a nice introduction you can use to show your students why this integral does give us an inverse trig function. Now, how can we use that? How can we think about it? Well, your students will learn some algebraic techniques for these sort of integrals here. What this is intended to show them is an alternative way of thinking about them, and I'd highly recommend doing this after they've learned the algebraic techniques. I wouldn't suggest this as an introduction. This is a nice extension to show them an alternative way of thinking about the result that they could obtain anyway by the standard algebraic techniques. I'm going to start by comparing the graph of 1 over 1 plus 4x squared to the graph of 1 over 1 plus x squared. You'll see the shapes are similar, literally similar in the mathematical sense. The other thing to observe is just what's happening to the blue curve for 1 over 1 plus x squared. And the key point I want to observe is this point here. 1 over 1 plus x squared drops half its height after x is 1. I'm going to use a made-up term to describe this, which is, I'm going to think about this as a half-life. I'm going to think about this point here, and I'm going to say on 1 over 1 plus x squared that the half-life, this is a made-up term, it's not a textbook term, but the half-life is 1. Basically, after 1, it's dropped half its height. I can use that to work out what transformation has been applied to the red curve. So, thinking similarly about the red curve now, I can say, well, this has dropped half its height here after x is 0.5. So on the red curve, thinking about the equivalent point here, I've got that the half-life is 0.5. Basically, the graph has been stretched in or squashed in by a factor of a half. Now I want to think about what the red area is. Well, the red area here at 1.5 is 3 lots of the half-life. So 1.5 is 3 lots of 0.5. What that tells me is, if I go back to my blue graph, is this red shaded area is similar, it's the same shape as the area under the blue curve all the way up to 3, but it's been stretched in by a factor of a half. Okay, I can think about what that means in terms of the integral then. That means this integral here is the same as the integral on 1 over 1 plus x squared from 0 to 3, but it's been stretched in by a factor of a half. It's a half as much. And then I can just literally write down the answer. This is a half, and all of this integral is arc tan 3, which is exactly the result that you or your students can confirm by doing this integral algebraically. Okay, in the accompanying video for this, we'll have a look at the other 2 questions on the sheet, but I suggest going away now and having a go and seeing if you can do the other 2 questions on the sheet, and then come back and watch video 3b.